So in this video, we're going to show you how to graph a cosecant graph. But first, we're going to find all the attributes so we can be able to graph it. So for this one, A, it's going to equal 2, as we can see right here. B is going to equal 2 pi. The phase shift here is not going to be 4 pi. It's actually going to be 2, because when you factor out the 2 pi, 4 pi divided by 2 pi is going to equal 2. K is going to equal 1, the vertical translation. The amplitude of this function will still be 2. The period will be 2 pi over the absolute value of b. And since the absolute value of b is going to equal 2 pi, it's going to be 2 pi over 2 pi, which equals 1. So the period here is going to be 1. And to find the tick mark width, we divide the period by 4, which is going to equal 1/4. And now, the first tick mark we know is h, the phase shift, so that'll be 2. And we have to add 1/4 to that, so we'll convert 2 into decimal form, or into fraction form, which will be 8/4 plus 1/4 equals 9/4. Add another fourth to that, which will equal 10/4. We can simplify that down to 5/2. Now 10/4 plus 1/4 is going to equal 11/4. And then finally 11/4 plus 1/4 is going to equal 12/4, which simplifies down into 3. Now we're going to show you how to graph this function.
So now we're going to graph this cosecant function. And so always when you graph the cosecant function, you first need to graph the sine function. So we'd have to graph y equals 2 sine of 2 pi times x minus 4 pi plus 1. And so first off, to graph this sine function, since the k value is positive 1, we know that we'd have to place the imaginary x-axis at 1. So we can just draw that in here. And since the amplitude is 2, which you can find out from the a value, it means the function will go up to a maximum of y equals 3 and down to a minimum of y equals -1. So we can go ahead and label that. And so the sine function, we'd have to start it off here at the first tick mark, which is 2, and it starts at the imaginary axis, so you just graph the sine function, and then to the next tick mark it go up to the maximum, and then it go back down to the x-axis, the following tick mark, and then it go back down to the minimum, and then it go back up to the x-axis. And so with the cosecant function, where this function crosses the x-axis, that's where the asymptotes are going to be. So the sine function crosses x-axis at x equals 2, at x equals 5/2, and at x equals 3. And when graphing the cosecant function, we start from the points where the sine isn't crossing the x-axis, where the imaginary x-axis of x equals 1, and you draw these kind of parabola shaped lines. You just draw them going away from the x-axis. And there you have it. This is one period of the cosecant function with parabola going up and a parabola also going down. And now we're going to move on to describing the transformations of the cosecant function from the original parent function. Here we're going to describe the transformations of this cosecant function from the original parent function. It's been vertically stretched by a scale factor of 2, which you can determine since the a value is 2. It's stretched because since the a value isn't between 0 and 1, it's going to be stretched. Horizontally compressed by a scale factor of 1/2 pi, which you can find out is compressed from the b value, and it's 1/2 pi because you need to find the reciprocal of the b value, and it's compressed because it's not between 0 and 1. It's vertically translated up 1 unit, which you can determine from the k value being +1, and it's horizontally translated right 2 units, which you can determine from the h value, or the phase shift, equaling 2. And those are the transformations of this cosecant function from the parent function.